Hello, wonderful people. Here we are. We're going to sum up chapter 33. Um, I am the red text reader. I am the blue text reader. Lucky me. Buttons, come on, buttons work. There we go. Chapter 33 covered electric fields and electric potential. And as soon as we get to 44, we'll start using the word voltage a whole lot. But we're still using electric potential right here, right now. Excuse me. Electric fields. An electric field fills the space around every electric charge. The field is strongest where it would exert the greatest electrical force on a test charge. So remember, we just picked a positive charge because Ben Franklin picked it. And if you imagine a positive test charge here, the pointer, what would happen? It's going to get repulsed by that positive test charge. So it's going to go out that way. That's why the arrows point away. Where's the field the strongest? Well, right down here where the lines are close together. So it's going to get pushed really hard there. And the further away it gets from this particular one or this one, the weaker it gets. Unlike this one, since all the lines are parallel in there, anywhere in here, it's going to have the same push going left to right. The direction of the field at any point is the direction of the electrical force on a positive test charge. Whoops, I explained that already. An electric field can be represented by electric field lines, which I also explained. Sorry. Static charge occupies only the outer surface of a conductor. Inside the conductor, the electric field is zero. So if you've got, this is the cross section of a wire and there's a whole bunch of electricity going through it, all the electrons repel each other, and so they all get pushed to the outside of the wire. And then with all that negative charge distributed around the outside, then there's no electric field on the inside. If it's just a wire with no electricity going through it, just an ordinary number of positive or negative charges, and an electric field passes by here, you can see it's going this way. So the negative charges get pulled in by the positive field there, and then the positive charges over here get pushed away from here, and they create their own field going out here. So once again, inside this conductor, the field is zero. There's a field coming into it and a field coming out of it, but inside the field is zero. All right, to be honest, this is a little bit more advanced than what I will cover on the test. You do have to know that inside the conductor, the electric field is zero. But I'm not going to ask you to explain the whys. You do have to know this. A charged object has electrical potential energy excuse me, by virtue of its location in an electric field. So we talked about this in class. I've got potential energy because I've raised it up and gravity's pulling it down. So when I snip the wire, that potential turns into kinetic. It gets pulled down and it becomes faster, faster, faster. The same thing with electricity. I've got this raised up and it has the potential to get pulled into here. So when you let it go, it turns into kinetic energy. And it's the same idea with like charges over in this picture. If I've got a positive charge here and a positive charge there, it takes work. I have to put work into it to push it against this repulsive field in there. Does that make sense? The space that surrounds each of these things, the magnet, the black hole, and the electric charge, is altered. Oh, I should have taken off all that bit. We're talking about, all you need to know is that the space is said to contain a force field. What is a force field? A field around the source of the force that has the force acting within the field. So there's the electric field. So if you have a positive charge out here, it's going to experience a force from this. So there's a force acting on it, and that force is carried from the field. So a field, what's a force field? A field around the source of the force that has the force acting within the field. You don't need to know that, but I do need you to understand what a force field is. It's a field, those are fields, and the result of this field is a force. Now, in the case of electricity, it has to be a force on a charge. In this case, if it's a positive charge, it'll push it away. If it's a negative charge, it'll pull it in. Okay? So that's the review for that chapter. Good luck. Thank you very much.